Welcome back to the ALKANOLS series, my beloved students. In the first series, I taught you the introduction of ALKANOLS, the met, the et, the prop, the boot, the pent, and the rest of them. So in this second series now, in this second video, we will now introduce the ALKANOL itself as a family of organic compounds. All right. Now, one thing I want you as a student to have in mind is that looking at this spelling of ALKANOLS, this N, which is OL, if you remove the S, that's the plural. But look at the OL. The OL there means all. That all means OH. And the OH is pronounced as hydroxyl. Is pronounced as the hydroxyl group. So in our study of ALKANOLS, take note of this. That's the meaning of all, which is OH, or the hydroxyl group. Now, that's the basic introduction of ALKANOLS. Okay? Now, the first key point I want us to take is this. ALKANOLS are organic compounds that have this OH as their functional group. Okay? So, they have OH, which is the hydroxyl group, as their functional group. Take note of that. Meanwhile, you as a student, I want to bring to your notice what the functional group means as a phrase. A functional group, you can take it down, is a group of atoms that determines the chemical reactivity of an organic compound. So please take it down that a functional group is a group of atoms which determines the chemical reactivity or behavior of an organic compound. So take that one down while we continue with our series of our study. Now, the next key point I want you to take note of is this. The general formula for ALKANOLS Now, take a look at this. The general formula for ALKANOLS is ROH or CnH2n plus 1 OH. Take note of that. Now, you might want to know what this R is all about. The R there means an alkyl group. So it means an alkyl what? Group. Take note. Now, very quickly, we will now go to the third key point of this lesson, where we'll be talking about listing down the members of the ALKANOLS or the ALKANOL family, and then drawing their structures. Now, the first member of the ALKANOL family the first member, remember what I taught you in the first video, met, et, prop, boot, and rest of them. The first member is methanol. methanol. Remember that met means one, as I explained to you before. So let's draw the shot of methanol. Met means one carbon atom with 4 bonds around it. I taught you this in the first video. Now, if you want to complete the structure or the drawing, you first put the ol. Remember I told you that ol means OH. So the ol, you put it here. This is OH, the ol. Then the rest of the bonds, you occupy them with hydrogen. This is the structure of methanol. Are we together? This is the structure of methanol. But this is the Kekule structure. You know, Kekule structure is a structure where you spread out the hydrogen. But if you now want to do the line structure, what we call the line structure, which you have learned from your previous studies of organic chemistry, the line structure will now be, you bring down the carbon atom, count the hydrogen atoms, 1, 2, 3, that is H3. Then bring down the OH. This is the line structure of alkanols. This is the line structure of methanol. This is the Kekule structure of methanol. So this one is Kekule. This one is the line structure. Please take note of this, very important. Now, the second member of the alkanol family is eth. Remember I told you that eth means 2 carbon atoms. So we have ethanol. Now let us do ethanol. Eth means 2 carbon atoms. So we have 1, 2. Now remember I told you you must put 4 bonds around every carbon atom. Okay, so this is what we have. Now we will put the OH, which is the ol. Remember what I told you. OH is the ol. Then you now occupy the rest of the bonds with hydrogen. So we now have, this is the Kekule structure. The line structure will now be 1 carbon atom, bring it down. You count how many hydrogen atoms it has. That's CH3. Bring down this carbon atom. It has 2 hydrogen atoms. You bring it down. Then the last one, which is OH, you bring it down. This is ethanol. Another way you can also do it is, you can count the carbon atoms we have here. We have 1, 2 carbon atoms. Write it as C2. You now count the hydrogen atoms we have. 1, 2, 3, 4, 5. Then you now bring down the OH. Please, this OH, the hydrogen here, don't count it. Count only the individual hydrogen atoms. Then you now bring down the OH. These are the 3 possible ways of drawing the structure of ethanol. Okay? Now, very quickly, look at the third family, the third member of the alkanol family. Now, the third member is propanol. That's propanol. Or you can call it propan 1-ol. You can call it propan 1-ol. Are we together? Now, let us draw propanol. Prop is how many? 3, as I explained to you. Prop is 3, as I explained to you. Remember, I told you must put all the bonds, 4 bonds around each carbon atom. You now put the ol. Now, this 1-ol, remember that the word ol means OH. This 1-ol means that you put the carbon atom, you put the OH, which is the ol, you put it on carbon number 1. So this is put it here. The rest of the bonds will now be occupied with hydrogen. So the rest of the bonds will be occupied with hydrogen. Okay. Now let us do it the other way around. So we have C, 1, 2, 3, 3 hydrogen atoms. We have another C again, 2 hydrogen atoms. We have another C again, 1, 2, 2 hydrogen atoms. We now have OH. Is it clear? So this is the next structure. The other way you can draw it. Then you can do it this way also. Count the carbon atoms. 1, 2, 3. That is C3. 1, 2, 3, 4, 5, 6, 7. That is 7 hydrogen atoms. Then now bring down OH. Is it clear? Now, these are the 3 ways you can do propanol. Now, to round off this video very quickly, I will show you another way in which you can do this. The one all here means that the OH is on carbon number 1. But let's round off the video with this structure. Propan 2-ol. Now, propan 2-ol, if you want to do that, you know it still has that prop. Prop is 3 carbon atoms. I explained to you. This is the usual prop that we have. Now, this 2-ol means that the OH, which is the ol, will be on carbon number 2. You see that the OH now is on carbon number 2. The OH is on carbon number 2. That's why it is 2-ol. Okay? Now, the rest of the bonds occupied with hydrogen. Okay? Now you can summarize it like this. CH3, that's bring down C. You now have 1, 2, 3, bring it down. Okay? We have this C here. This C here is carrying the OH. So I put the OH on top. Then the hydrogen will join it like this instead of spreading out. Then the remaining carbon atom now, we have 1, 2, 3, 3 hydrogen atoms. Now, have you noticed something? The number here tells you where the OH should be. The OH here now, which is all, is on carbon number 2. So I put it on carbon number 2 here. And that's what we have. These are 2 ways you can draw propan 2-ol. That's it for this video. In the next video, we will now go to the IUPAC nomenclature of alkanols. Okay? I urge you to come around for the next video. Follow this series and complete it. And you will be very proficient in alkanols as a topic. Thank you very much.